Alright, finally it's time for the solutions for the use matrices to solve systems of equation assignment. So on this first section here, you just have to figure out what row operation was used to get from our starting augmented matrix here to get to each of these. So it's from the start to there. Each one is just a different row operation. So on this first one, I noticed that the first row is the same, but the second row is really similar to my starting second row. It's just times by 3. And so the row operation would be row 2 times 3. And then on the next one, I notice my second row is the same. But my first row, I think, is just those added together. If you check that out, it comes out okay. And so this one is just row 1 plus row 2. And on the next one, here, I notice how my first row stays the same, but my second row is actually quite a bit larger. But looking at this first one, I notice I go from 4 to 34. You can't take 4 and times by something to get up, well, times by a whole number to get up to 34. And so I'm thinking you actually added a multiple of this one. If you do 15 times 2 and you added it, you'd get 34. And on the next one, if you do 11 times 2, that gives you 22. If you add that to negative 3, oh, that gives you 19. So it's looking like this one is row 2 plus 2 times row 1. Okay, so it's like multiply the first one times 2 and then add it to the second row. Anyway, and that brings us to our last one. I notice that this is the same, but my first row is not. If I go from 15 to 5, that's like dividing by 3. Well, let's see if the next one is the same. Oh yeah. So it's looking like this is just row 1 divided by 3. And that's our first one. Let's move on to these ones. On these ones, you need to set up your augmented matrix. So that's the x coefficient, that's the y coefficient, and the 14 on the end, the x coefficient, the y coefficient, and then the answer on the end. And so now I need to take this and turn and do row operations, so this becomes the identity matrix or the reduced row echelon form. I notice right here at the start I can take row 1 and subtract 3 times row 2, and that'll make this 0, which would be awfully convenient. I'm going to leave row 2 the way it is. Temporarily, row 2 multiplied by 3 is 3, 9, and 3. So that's going to give me my next matrix here. 3 minus 3 gives me 0. The negative 2 minus 9 gives me negative 11. And then the 14 minus 3 gives me 11. And on the bottom I still have 1, 3, 1. I'm going to leave row 1 the way it is for a second, but I'm going to take row 2 and divide by negative 11. And that'll make it so it's 0, 1, and negative 1. And my second row is the same way that was. And now I'm going to take row 1 and let it be the same, but I'm going to take row 2 and subtract 3 times row 1. Because if I do 3 times that, that'll give me 3 and negative 3. And if I subtract that from these ones, this will be a 0, which is one of the goals. And that's going to give me 0, 1, negative 1, that's a 1. And then 1, 3 minus 3 is 0, and then 1 minus negative 3 is 4. So now I have this, and if I were to transfer that back into a system, I'd have 0x plus y equals negative 1, and then x plus 0y equals 4, and so x is 4, y is negative 1. And that's my solution to the system. Ta-da! Moving on to the next one, I'm going to transform that into a matrix and do my row operations. It's going to be negative 2, 1, negative 3, and then 1, negative 4, negative 2. And now I have this. I notice if I take row 1 and I add twice row 2, this will give me a 0, which would be great. I'm going to leave row 2 the way it is. So if I do row 1 times 2 real quick, I get 2, negative 8, and negative 4. I'm going to add these to these ones. That'll give me 0, negative 7, and negative 7. The next one is just row 1, negative 4, negative 2. I'm going to take row 1 and divide by negative 7, and leave row 2 the way it is right now. That'll give me 0, 1, 1, and then 1, negative 4, negative 2. That's 4. And now that I have this, I'm going to take row 2 and add 4 times row 1, and leave row 1 the way it is. Row 1 times 4 is 0, 4, 4, just temporarily. If I add that to row 2, I'm going to get 1, 0, 2. And on top I have 0, 1, 1. And if I were to rewrite this, I'd have 0x plus y equals 1, and then 1x plus 0y equals 2. And so x is 2, y is 1. Ta-da! So there's that one. Let's move on to 7. Transform this into a matrix. There's my x coefficients, my y coefficients, and then my constants on the right side. I need to transform this so it's the identity matrix, or the identity matrix upside down, like I've been doing the last two. I noticed right away that if I were to add these, or if I were to come over here and add 3 times the second row, I'd get a 0. I think the path I'm going to do this. I'm going to go for a 0 there in that second column. So I'm going to take row 1 and add 3 times row 2. And I'll leave row 2 the way it is right now. Actually, I'm going to take row 2 and divide by negative 2. That'll give me some 1s there, and that might be a little bit easier to deal with later. Anyway, so if I take row 2 and times by 3 temporarily, I'll get negative 6, and 36. I need to add these to these ones. That will give me negative 3, 0, and 30. And my second row, I'm going to have 1, 1, and negative 6, because I divided everything by negative 2. And now that I have this, if I take row 1, actually, interesting. If I take row 1 and divide by negative 3, this is going to turn into a 1, which would be great. And I'm going to take row 2 and let it be the same for now. This is going to get 1, 0, negative 10. And then I have 1, 1, negative 6. If I then take row 2 and subtract row 1, I'll get a 0 there. And then this one will be ready to go. 1, 0, negative 10. 1 minus 1 is 0. 1 minus 0 is 1. 6 minus negative 10 gives me positive 4. And now if I were to transform that back into a system, I'd have x plus 0y equals negative 10. And then 0x plus y equals 4. And so x is negative 10, y is 4. And that one's done. Let's move on to 8. Again, we need to transform this into a system. There's our x coefficients, our y coefficients, and our constants on the right side of our equations are those. I notice right now that these ones are kind of not the easiest ones to become 1s. But if I were to take, say, let's see, if I were to do like 4 times this row and add it to this one, I'd get a 1 here. Or I can do negative 4 times this and add this, and that'll give me negative 1. So I think I'm going to do that. I'm going to do row 1 plus negative 4 times row 2, and leave row 2 the way it is right now. Let's see. Negative 4 times this gives me negative 16, positive 12, and I actually don't know what that is right now. Hold on. Okay, it gives me 104, and now I need to add this row to this row, and my second row is the same, so 4, negative 3, negative 26. But my other one is going to give me negative 1, 23, and 140. So now that I got this, I'm going to take row 2 and add 4 times row 1, because that'll give me a 0 right there. And I'm going to take row 1 and just divide everything by -1 to make that positive there. So this is going to give me 1, -23, and -140. And temporarily I need to times all that by 4, so that's -4 here. Let me get the other ones real quick. Okay, so 23 times 4 is 92, and then 140 times 4 gives me 560. I'm going to take those and add them to this row. That gives me 0, and then 80, so let's see, 92 plus -3 is 92 minus 3, so 89, and then 560 minus 26 is going to give me 534. Okay, so what I'm going to do now is actually take row 1 and let it be that for a second. I'm going to take row 2 and divide by 89. I'm kind of tired of those really big numbers. I'm hoping it turns out okay. If it doesn't, then that'd be a shame. Well, let me see. Awesome, it does turn out. So this one comes out to be 6. Yay! And now I can do row 1 plus 23 times row 2, and that'll get this to be a 0, which is the goal. And we'll leave row 2 the way it is. And so it's going to give me 1, 0, and 26 times 6 times 23 is 138, so I need to do 140 plus 138, just gives me -2. And my second row is the way it was. And yay, even though it was kind of messed up there in the middle with some big numbers, we come out on the end on top. The first number is the x value, the second one is the y, so x is -2. And the next one, y, is 6. And that one's good to go, so there's up to 8.